Please. Hey, everybody. Today's September 25th. It's Earth Science. I'm Mr. Sheridan. I hope you're all having a great day. We're going to do a couple of things in our instructional video today that we don't usually do. So if I can have all of you jump in and make sure that your names and your videos are off and your names are changed and all that good stuff, we're going to go in and actually go through the entire quiz that we took on Tuesday. So the Sun and the Stars quiz, here we go. First question, how many layers does the sun have? The sun has 6 different layers. Again, right now, if you have questions or need some clarification on any of this stuff, please write them down and I'll be happy to answer any questions that you have, or you can email me if you're watching this later. So the sun has 6 layers. Which layer produces the energy that we use on Earth? The answer is the core. The core is where nuclear fusion happens. It's where it's so hot that particles or atoms of hydrogen actually bump into each other so much that it creates helium. So, and energy. There's other parts of that equation too. And the energy is what we use on Earth. So what layer can we see from Earth? The answer is the photosphere. We can see the photosphere from Earth. What layer do you see during a total solar eclipse? The answer is the corona. When you cover up the center of the sun, the part that's around the outside is the corona, the outer layer, the most outer layer. Describe what happens in the convective zone. Okay, here's what I was looking for. So the convective zone is the 3rd layer from the center of the sun. So you got the core, and then you have the radiative zone, and then the convective zone is outside of that.
You're so cool, dude. Number 11.
What happens in the, I need everybody to be on mute, please. So in the convective zone, what happens is, or what I'm looking for, is that material is being heated by the radiative zone, and so it's rising through the convective zone, and then it cools as it gets to the outer part, and it's falling back down again until it heats up enough to go back up and down. That's what we call convection, when that heated material is moving up until it cools and then moves back down. List the layers of the sun in order from the core to this is cut off, but it says the corona. So the core is first, then the radiative zone, then the convective zone, then the photosphere, then the chromosphere, then the corona is the correct order. Where are stars formed? I needed you to use the word nebula. A nebula is a gathering of dust and gas in space, and eventually when all that stuff starts to come together and starts to create gravity, that's when stars are formed. How are stars characterized? This one tricked a lot of people because we do talk about size and we do talk about how old stars are, but the way that they are characterized and the way that we put them into categories, that's what this means, is by color and by temperature. And I was going to show you one of the way that we, or the slide that we did this in. Here we go. Right here. Color, temperature. That's how we actually distinguish and we classify different stars. Okay, so let's keep going here. What causes a star to move from a main sequence star to a red giant is what this is going to say. And the answer is that it runs out of helium. If there's no more helium to create fusion, then that star starts to expand. So I needed to hear that you knew that it was not, that it runs out of helium. In a star's life, which comes first, a red giant or a white dwarf? A red giant comes first, so that's the answer. And then when a red giant runs out of helium, then it turns into a white dwarf. What is the heaviest element formed through fusion? The answer is iron. So what happens right before a supernova explosion is that even when stars turn into red giants and when we're talking about when they get even bigger, when we're talking about supergiants, then a star is still able to create nuclear fusion. There's still those, it's still very dense and there's a lot of energy there that's moving those particles around, so it's creating new atoms. But once it gets to iron, it no longer can create nuclear fusion, or it's not going through the process of nuclear fusion where elements are bumping into each other so far that they're actually creating new elements. So what happens is called a supernova explosion, and that's where we get heavier elements. So as we're going to answer a couple of these here. So iron is the answer here. What causes a supernova explosion? That nuclear fusion stops, or that it's all iron. That's what causes the supernova explosion, and the result is that we get more heavier elements. Everything on the periodic table that's higher than 17, which is where iron is, that's what we're talking about when that's the result of a supernova explosion. So I want you to go back and take a look at that, see what answers maybe you missed, maybe you didn't. But the other thing that you need to do today, if you go into your Google Classroom, is first of all, always do your daily attendance and your daily check-in. But then I need you to go down here, and there's one more CK12 that I want you to do today. And you're going to add 2 more vocabulary words, cosmology and universe. And then you need to go through, read, watch the video, and take the quiz. Make sure that you're turning that quiz in CK12. Okay? Hope you're all having a great day and have a great weekend. I will see you all on Monday.